As John mentioned earlier, which we talked about not doing, and I did anyway.
It's okay. This is why we train.
Okay.
Hi, I'm John Grunsfeld, NASA astronaut.
Hi, I'm Christy Hansen, Johnson Space Center EVA Task Astronaut Training Lead and Flight Controller.
And EVA means extravehicular activity, which is just another long way of saying spacewalk. And I got to do 8 spacewalks on the Hubble Space Telescope. You might wonder, how did we learn to do the complex tasks using all the cool tools that we used on the Hubble Space Telescope? Christy, how did we learn how to do all of that?
So as the EVA Task Training Lead, one of my big duties was to work together with the astronauts for about 2 years, as well as my Goddard engineering colleagues, to develop tools, techniques, and procedures to train crews. But generically from Johnson Space Center, I had to train the crew on how to work on mock-ups that simulated flight-like hardware on orbit. And there are various venues that we did that. So the neutral buoyancy tank is a giant swimming pool that's 40 feet deep, 6.2 million gallons of water, and we can take mock-ups, which are volumetric equivalents of space tools and science instruments on orbit, take them down under the water and put them in flight-like positions. Volumetrically similar meaning same size, screw positions are in the same location, distances from point A to point B are the same as what you'll see on the telescope. So in the neutral buoyancy tank, we have a mock-up of the Hubble Space Telescope. So it's built out of different materials with holes in it, because you don't want a heavy metal object in the pool. But in terms of distances to a science instrument or like a handrail sill, those are all the same.
This particular mock-up, which means model of what we have on orbit on the Hubble, I actually had on my desk for a long time because I wanted to practice over and over and over again. My goal was to memorize, to learn every single screw of the hundreds of screws that we had to remove on Hubble, so that when I got to orbit, there were no surprises. Same for how to use the tools, how to turn the lights on, run the tool, change the torques, change the direction of the tool. All those things had to be second nature. So when I got to orbit, it was just about fixing the Hubble. Sometimes I would come to the Goddard Space Flight Center where we had the full mock-up of the camera, and I would put on EVA gloves, spacewalking gloves, and practice removing the screws and doing the whole task.
And one thing about doing these tasks at Goddard, because they did have higher fidelity mock-up units in the Building 29 clean room, was understanding not only the tasks at hand, but what areas you can't touch when you're in a spacesuit. So in a higher fidelity volumetric simulator at Goddard, for example, when John is performing the duties on this advanced camera for survey upgrade task, he can look around inside the telescope and it looks more like what it would actually look like in space, as compared to the neutral buoyancy tank where you just see kind of a lot of plastic around you, and you can envision there are certain areas like seals and radiators that you're not supposed to touch and sharp edges. So you piece all those parts together. We also have the virtual reality lab. So the pool, the pool is good for body positioning and translating and managing tools, but it's not really good because there's drag in the water, right? So you're moving a mock-up, but you're not really feeling what a 500-pound mass feels like. So we take that into the virtual reality lab where we have a mass simulator called Charlotte, and we can take the giant axial instruments that weigh, 800, 900 pounds, or a battery, put in all the mass specs into the simulator, and then the crew, like John, can stand there with a headset on that makes it look like he's in space, holding handrails on a mock-up, and simulates what it would feel like to move an 800-pound mass around an orbit.
All in all, the tools, the training, the mock-ups allowed us to repair and upgrade the Hubble Space Telescope so that now it's doing better than ever.
Ready? Should I start?
Just don't be late.
No, don't be late. I hate when people are late, by the way. Okay, ready?
Hi, I'm John.
Do I need to do this?
Do it again, one more time.
Okay, ready?